Have you ever wondered how scientists prove or disprove all sorts of stuff, ranging from correlations between a certain drug and cancer risk to the way animals behave? Well, depending on what is being studied, researchers can use more than one research method to find out more about their questions. You may have even employed some research methodology as you observed your little brother and tried to figure out why in the world he's sucking on his thumb. Your observations fell into the category of observational research, which is a type of research method that records observations of phenomena. So, as a more appropriate example, perhaps you are studying for possible behavioral changes in primates after they give birth. Maybe you travel to the rainforests of Africa or to a zoo to watch how a mother-to-be changes her behavior before and after birth, how long she performs each behavior, and so on. Observational research may be split into naturalistic observation and participant observation. In naturalistic observation, the observer sits back and watches behavior without manipulating different variables that may influence the results. It would be like watching a bunch of people sitting in an ice cream shop from afar. This is in contrast to participant observation, where the researchers insert themselves into the group being observed. Meaning the researcher goes to the ice cream shop, buys some ice cream, and sits and even interacts amongst the people he or she is observing. Observational research is a type of correlational research, a research method that examines statistical relationships between variables. A famous example of correlational research is smoking and lung disease. Lots of data on these variables is collected, and it is then analyzed to figure out if there is any covariation between the two. However, you shouldn't immediately think of this as a cause and effect type of research just because of what I said. A simple explanation from one of my favorite books, The Art of Happiness, will point out what I mean. This book, written by the Dalai Lama and psychiatrist Howard Cutler, had a little interesting section. In short, very intelligent researchers were positing that mood changes occurred as a result of chemical imbalances in the brain, a type of cause and effect belief. But the Dalai Lama asked them, why couldn't it be that the mood changes caused those imbalances? And despite not being a man of science, he is a man of wisdom, for he is completely correct. Emotional changes themselves, triggered for any number of reasons, can cause new chemical imbalances in our body, and vice versa. Unlike correlational research, experimental research is a type of research that provides strong evidence for cause and effect relationships. A real experiment is where we try to control all variables except for the one we are studying. Experimental research need not always be a laboratory study, but it's often easiest to do so there since so much can be placed under our direct control. Experimental research allows the researcher to manipulate a variable they are studying. Such a variable is known as the independent variable and is like our cause. The variable reacting to the manipulation of the independent variable, one we believe may be being affected by it, is known as the dependent variable, for it supposedly depends on the independent one. A possible such study design may manipulate the noise level people are exposed to while they sleep in identical rooms and conditions to see how varying noise levels affect the amount of time a person spends in the deepest stages of sleep. This lesson went over 3 types of research methodologies. Observational research is a type of research method that records observations of phenomena. Observational research may be split into naturalistic observation and participant observation. Observational research is a type of correlational research, a research method that examines statistical relationships between variables. And we finally went over experimental research, which is a type of research that provides strong evidence for cause and effect relationships.